In this example, our parent function is the cube root of x. Y is equal to the cube root of x. I will sketch a graph of what that function looks like and conveniently choose some points that are on this function. So the graph of the cube root of x looks like this. Some points that are on this graph are the points -8, -2, 0, 0, and 8, 2. And then I'll also make a table with those points, which is our other alternative as opposed to making a graph. This function only has one transformation. It is the 4 that is now on the inside of the function with the x. The equation has changed because we have replaced x with 4x. And it's worth noting that the absolute value of 4 is greater than 1. Let me move this. That is the difference between this equation and this equation. So what that first transformation is, looking back at our table, if we take x and we replace it with ax, where a is a number whose absolute value is greater than 1, we're dealing with a horizontal compression. So we're going to be dividing our x coordinates by 4 in order to get our new table. Now the graph is not going to look that much different at all. So on some functions, it's difficult to see. First, let me just write horizontal compression. Or you could say a horizontal shrink. Either one would be fine. And because remember, inside things happen backwards. So even though 4 is bigger than 1, that's still a compression. So I was saying that the graph isn't going to look much different. On some functions, it's very difficult to see compressions and shrinks. But that is why we are labeling the points and also, or doing the tables. So even if the graph looks the same, we can still tell that the graph has been transformed. Because in order to compress horizontally by 4, we need to divide our x values by 4. So the y values of -2, 0, and 2 in the table will stay the same, but -8 will get divided by 4 to give -2, 0 will get divided by 4 to give 0, and 8 will get divided by 4 to give 2. And so now I'm just going to sketch the same shape of graph and just label the points that we already know are on the graph because we are dividing our x coordinates by 2, and that is our final graph because this function only had one transformation.